This video is part of a playlist. You should have viewed the introductory example and the previous example. I'm going to provide a link to both the original problem and the previous example that built on that. What we're going to take a look at now is what if we change the other coefficient of the objective function. I aim to show to you that we could have the coefficient of x sub 2, aka y, be between the following values. My claim is that if we call that d, it can be between 5 and 40. It can be exactly equal to 5 or exactly equal to 40 or anything in between, and still have that point C with the coordinates 120, 60 be the point, be the corner out of those four corners of that bounded feasible set that will still produce the maximum for this equation. So looking at lowest possibility it could be is 5. And the highest it could be being 40. Oh, didn't want that one to be changing. Go. Get that one to change. So remember, as in the previous example, what we want to do is get the slope of the profit line to both match up for a value of d, match up with the slope of this line segment and with this line segment. So what's going to do that? Rewriting the objective function to get x sub 2 alone, i.e. y. I'm going to subtract the 10x1 and then divide everything on both sides by d, so that the slope of the isoprofit line, oh, that's a typo. That should be negative 10 over d is the slope. I had, unfortunately, did a copy and paste from the previous problem. Negative 10 over d. We already found out in the previous example that when we replace the less than or equal to with equal and solve for x sub 2, i.e. the y variable in our regular constraints, that the slope of the first one is negative 1/4 and that the slope of the second one is negative 2. So when we set each of those equal to the slope of the isoprofit line, negative 10 over d, that gives us, solving negative 10 over d equals negative 1/4 for the first one, that d equals positive 40. And when we set it equal to negative 2, cross multiply, negative 2d equals negative 10. So d equals 5. And that gives us that d would be any value inclusively in between 5 and 40, including those endpoints, and we'll still get our maximum at the maximum, at the same corner point as we did when we were not changing the coefficients. It's going to be at the point 120, 60. However, with a different value for d, it's going to give us a different maximum, but it will still be the maximum with that new value of d.